the mechanism of micelle formation. How the micelle is formed. In the previous video, what is the micelle? At what concentration it will form? We have discussed that example. Now let me see the mechanism, how it will form. The mechanism of micelle formation. Right? Now if you consider this one, then the mechanism of the micelle formation. Let us take the example soap solution. If we take what the example for the micelle I have taken, soap solution I have taken. Now, the formula of chemical formula of the soap is RCOO minus Na plus. This R is nothing but C17H35. C17H35 and COO minus Na plus is the common. The name is called what? Sodium stearate. This is the name you are calling as what? Sodium stearate, which is actually the soap particle. So here we can take sodium or we can take even potassium also we can take. So this is a soap particle actually, whatever we written. Now you see the C17H35 I am writing here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So up here how many? C17. Up here what happens? C17H35 COO minus. Now I am writing this part. This entire part is very length it is. So this I am calling as a tail part. This part I am calling as what? Tail part. This is the entire thing is called what? Tail part. This part can be called as tail part. And the small part, call this one as a head part. So it looks what? Like this. Head and tail part. Now head part is not having any negative and positive charges. This is non-polar. This one is the non-polar. Whereas head part is having polarity because of negative and positive. This is what? Polar. So here the micelle will get by using the soap part. This is a soap particle. The soap particle, if you observe what happened, when you dissolve these soap particles, many number of soap particles in the water. Okay, now what happens if you observe? Now I told you this is non-polar. Non-polar does not dissolve in the water. Therefore, this part is what? Hydrophobic part. This part. Tail part is called hydrophobic part. And the small part which is having charges here. So this is having charges. This is what definitely will dissolve in the water because having these charges will dissolve in the water. So it is called hydrophilic part. This polar part can be called as hydrophilic part. The head is nothing but hydrophilic in nature. Now, this tail part definitely water hating part, whereas the head part water loving part. Okay. Now, whenever if you dissolve these soap particles in water, definitely water will be attached on head part and water will stay away from what? Tail part. Okay. So if you take this soap particle, water will be attached to which part? Head part, and water will be away from which part? Tail part. Because tail part is non-polar. Now what happens here? I have taken many number of what? Soap particles here in what? Water. That means we are adding some soap in the water. And it's dilute solution. When you add small amount of soap in water, nothing happens. It acts as electrolyte. The soap particle acts as electrolyte. But when you increase the concentration, that means if you add a little bit what? More amount of soap particles in the water. Now what happens here? Because you are increasing the concentration of what? The soap. Now these soap particles are aggregating this. They are aggregating like this. When you increase the concentration, now they are aggregating. This is called what? Micelle. This you are calling as what? Micelle. This you are calling as a micelle action. Okay. Now if you observe what you are getting in this case, hydrocarbon chain, the hydrocarbon chain, the tail part towards the center of the sphere, the head part outside of the sphere. Whatever the head part, if you observe this one, the outside of the sphere, the tail part is towards the center of the sphere. In this way it is arranging here. So you are calling this one as a micelle. The aggregate form is called as a micelle. The aggregate form of these soap particles, when you increase the concentration from dilute, then you are calling that one as micelle. Similarly, in the case of detergents also. Detergent means this one will be the detergent. CS3, CS2 taken 11 times. That means C12 H, isn't it? Something 25 something like this. SO3 Na plus. Also will have this part will be again tail part. This part will be what again? Head part. This will be what? Hydrophilic character. This will be hydrophobic character. Water will be attached. Water will be away from him. So it can also form same micelle formation. Just only the formula is for change that. How we clean? How the soap will clean the stains here? How the what is the action of the soap on the, isn't it? This the action of the soap on whatever the dirty, how you are removing the stains actually. So when you clean your hand with soap, what mechanism is happening in this case? Now let me see this one. Definitely micelles are forming in soap. With water, what happened? Micelles are forming. Okay. Now what happens in this case? Now this you take as a strain, a grease product, a strain, the dirty particles, this one. Now when you are adding this, isn't it, into soap, okay, what is happening? Micelle is formed. Micelle is formed. Okay, this is a particle, colloidal particle, right? Soap particle. Now, whenever what happens, a micelle is forming like this. Here, micelle is formed. Okay, isn't this head part is away? The tail part is towards the center. Micelle is formed. Now, since I told you head part is a polar part, so it will attach with water. Where tail part, if you observe, they are non-polar. Okay, they are non-polar. They are away from water actually. Okay. Now, when you wash the clothes, what happens here? Formation of the micelle like this. When you wash the clothes, what happens here? So, what is happening if you observe? Right? This particle is the particle. This particle, what happens? Water will now bind at this one. When water gets binded, so when you are washing this clothes, otherwise you are washing the hands, what happened here? The water which is binding with what? The head part, right? And the stains, if you observe, the stains will have non-polar character. So tail is having non-polar character. And the stains, the dirty particles also will have non-polar character. Now, this tail part will attach to stains. The tail part attaches to what? The tail part attaches to stains. Head part attached to water. Now, when you wash the hands, what happened? These micelles are going along with water. They are washed away along with water, and this micelle in which the head part is attached to water and the tail part attached to the stains. So when you wash with water, water will attach with head part, tail part is attached to what? Stains, and everything will be washed away. So in this way, what happened, isn't it? The cleaning action of soap we can explain. What will be the answer? Cleaning of action of soap is due to formation of what? Micelle only. Now this is about the mechanism of the